This lesson will illustrate the procedure for multiplying a binomial times a binomial using both FOIL and area methods. You should already know that a monomial is a one-term expression. Mono implies one. Examples are 4x minus 2067, x squared, 8y squared. A binomial is a two-term expression. Bi implies two. For example, 3x minus 1, x squared minus 3x, 2x plus y. Trinomial is three-term. Tri implies 3. X squared minus 3x plus 1, 4x squared plus 6x minus 3, or 4x plus 2y plus 7. A polynomial is an expression with one or more terms. Poly means many. X squared plus 2x, 4x cubed plus x squared plus 5x plus 6, or 5x minus 2y plus 7. Think cycles. Monomial, think monocycle. Binomial, think bicycle. Trinomial, think tricycle. Here are some reminders for multiplying before we begin. We can multiply terms regardless of whether or not they are alike. When multiplying like bases, you add the exponents. You can distribute twice, resulting in the FOIL method. You can use a box to organize your work using the area method. We will use both methods when illustrating examples. Multiplying binomials is one of those skills that can start out slow, but with some practice become fast and easy. This lesson is here to help you move from slow and unsure to fast and confident. Generally, binomial multiplication means each of the two terms in the first binomial is to be multiplied by each of the two terms in the second binomial. There's a handy way to help us remember to multiply each term called FOIL. It is an acronym for first, outers, inners, last. So you multiply the first terms of each binomial, then the outers, the outside terms of each binomial, then the inters, the inner terms of each binomial, and finally the last terms of each binomial. Let us try an example. The product of x minus 3 and 2x plus 1. Let's make things easier by changing the subtraction symbol to adding a negative number. We are just applying the distributive property twice. Multiply the two first terms, x and 2x, we get 2x squared. Multiply the two outer terms, x and 1, we get 1x. Multiply the two inner terms, negative 3 and 2x, we get negative 6x. And then multiply the two last terms, negative 3 and 1, we get negative 3. Adding together like terms, we come up with the result 2x squared minus 5x minus 3. Now that was exhausting. Let's learn another method known as the area method. First, you draw a 2 by 2 box or table and label one binomial on top, one on the column. It doesn't matter because multiplication is commutative. Then you multiply each factor in the row with each factor in the column and write the products inside the boxes as shown. Then when we combine them all together, we get 2x squared plus x minus 6x plus negative 3. And combine like terms, we get 2x squared minus 5x minus 3. And we're done. And now it's your turn. Multiply 3x plus 2 and 4x minus 5. You may want to pause while you work on this. Here's the solution using the FOIL method. You multiply the two first terms and get 12x squared. Multiply the two outer terms and you get a negative 15x. Multiply the two inner terms, you get 8x. And multiply the two last terms, you get negative 10. Combining terms, we get 12x squared minus 7x minus 10. or the solution in the area method. Again, a 2 by 2 table, multiplying each column by each term in the row. And it gives you the same results, 12x squared minus 7x and a minus 10. Our last example will stray away from the title of this lesson. You might call it an extra credit example or a preview into a future concept. The reason I'm doing this is to show you that the skills you're mastering now can help you do more than just multiplying binomial. Take the example x plus 2 binomial times the trinomial x squared plus 5x minus 3. Here you make a rectangular chart, 2 terms on one side, 3 terms on the other. And then you fill in the chart by multiplying each column by each row. Combining like terms, we get x cubed plus 7x plus 7x squared plus 7x minus 6. Now let's review. 2 binomials can be multiplied using both the FOIL and area methods. The area method can be used to multiply any 2 polynomials, not just binomials. Simply make your chart have dimensions equal to the number of terms of each polynomial. Hopefully you're starting now to feel like you are a polynomial pro.